The goal of my project was to determine the effect of prescribed burning on prairie health. The independent variable I looked at was the amount of elapsed burn time since a section of prairie was most recently burned. Prairie health was measured by looking at plant biodiversity as well as the concentration of nitrogen and phosphorus within the soil. I hypothesized that the plots of prairie with the shortest elapsed burn times would have the greatest amount of plant biodiversity as well as the highest concentrations of nitrogen and phosphorus. I collected all my data at Cowling Arboretum of Carleton College in Northfield, Minnesota, and I looked at 3 different sections of prairie, each with varying elapsed burn times. I measured plant biodiversity using a quadrant sampling method and standardized all my data using Simpson's Diversity Index. For my soil nutrient data, I used a soil auger to collect soil samples, and these were analyzed using the Lamont Soil Test Kit back at the lab. As you can see from my results, in terms of plant biodiversity, the plots of prairie that were burned most recently had the greatest amount of plant biodiversity. And the same was true for the phosphorus concentration in Figure 2. As you can see, the plot of prairie burned most recently had the greatest concentration of phosphorus. However, my hypothesis was not supported with nitrogen concentration because the plot of prairie burned least recently, so with the greatest amount of elapsed burn time, had the greatest concentration of nitrogen. And so, as you can see, the conclusions that we can draw are that elapsed burn time negatively impacts plant biodiversity as well as phosphorus concentration. However, the opposite is true for nitrogen and nitrates. Further studies would be really helpful to determine if this pattern will hold true with more samples.